In the vast emptiness of space, humanity inches closer to a future where off-world habitats dot the landscape of other planets, and at the forefront of this cosmic construction revolution are autonomous construction robots. These marvels of engineering, designed to withstand the rigors of extraterrestrial environments, are not mere figments of science fiction, but a tangible reality we are crafting to extend our reach beyond Earth. Tasked with building habitats on worlds not designed for human life, these robots herald a new dawn of space colonization, an endeavor brimming with technological challenges and scientific opportunities. Set against a backdrop of harsh planetary surfaces and extreme conditions, the autonomous construction robots are the vanguards of our interplanetary future, piecing together the dwellings that will shelter the first off-world pioneers. Autonomous construction robots designed for building habitats on other worlds embody a convergence of robotics, artificial intelligence, materials, science, and space engineering. These sophisticated machines are equipped with onboard systems capable of navigating unpredictable terrain, utilizing resources found on the foreign soil, and constructing habitats that could withstand the variable atmospheres and gravitational conditions of different celestial bodies. To understand how these robots are transforming the future of space colonization, we must delve into their design. Each robot is a symphony of sensors, actuators, and computational power. The sensors feed real-time data to the robots, encompassing everything from the 3D topography of the surrounding landscape to the immediate texture and composition of the soil. Actuators, the muscles of these machines, translate digital instructions into physical actions, working in unison to manipulate materials, operate construction tools, and traverse the terrain. The computational core of these robots is where the magic happens. Algorithms process the sensor data, plan tasks, and coordinate movements with precision that human hands could hardly match in such an alien environment. Construction in space is not just about physical building. It's about creating sustainability through in-situ resource utilization, cutting down the impracticality of transporting vast quantities of materials from Earth. These autonomous construction robots are equipped with advanced techniques like 3D printing and can use regolith, the pulverized rock and dust, covering the surface of planets like the Moon and Mars, to create building blocks for the habitats. This not only makes the construction process self-sufficient, but also paves the way for structures that are uniquely tailored to their environment, offering better protection against radiation, micrometeorite impacts, and thermal extremes. The robots are also designed to work in swarms, a synchronized ballet of machines that can scale up operations from individual elements to entire settlements. This swarm technology is based on collective intelligence principles, where each unit contributes to a larger goal, adjusting its role and tasks in response to the needs of the mission. This offers redundancy, ensuring that if one robot fails, others can adapt to take over its responsibilities, making off-world construction resilient against the failure of single points. One of the main visionaries pioneering the development of these robots is the space agency NASA, which has invested in projects like the Robotics Construction Challenge, seeking to refine the technology that will build lunar bases. Similarly, the European Space Agency is exploring the possibilities with its regolith-based 3D printing initiative. Private companies like SpaceX and Blue Origin, with their own interplanetary ambitions, are also likely to enter the fray, bringing with them innovations that could further advance the capabilities of construction robots. A testament to the potential of autonomous construction in space was demonstrated through the Lunar X Prize, which saw teams from around the world compete to design robots capable of traveling across the lunar surface and building habitats. The competition showcased prototypes with different approaches to the challenges of off-world construction, ranging from robots that can burrow into the lunar regolith to create subterranean shelters, to those using solar sintering to fuse the regolith into solid structures using only sunlight. These autonomous construction robots represent more than technological feats. They are the harbingers of a philosophical shift in our relationship with the cosmos. They stand as ambassadors of human ingenuity, laying the groundwork for communities beyond Earth's confines and challenging us to rethink what it means to be an interplanetary species. The habitats they will build are not just protective shells. but the seeds of new societies, cultural melting pots, where the identity of being human will evolve in directions as uncharted as the landscapes these robots will traverse. The journey towards realizing autonomous construction robots for off-world habitats is still fraught with technical hurdles. The robots must be highly reliable, with self-repair capabilities to address the inevitable wear and tear of extraterrestrial conditions. Energy consumption is another critical factor, as these machines must be efficient enough to sustain operations using limited power sources, such as solar energy, which can be scarce or intermittent on other planets. Communication delays, which can range from seconds to minutes when operating from Earth to the Moon or Mars, pose another challenge, necessitating a level of autonomy that allows robots to make on-the-fly decisions without human oversight. Another important consideration is the adaptability of these robots to different environments. For instance, building on the Moon, with its vacuum conditions and microgravity, differs significantly from Mars, with its thin atmosphere and dust storms. Each scenario requires unique solutions, such as magnetic systems for collecting lunar regolith or wind-resistant structures on Mars. The development of autonomous construction robots also raises ethical and legal questions about the responsible use of space resources and the preservation of celestial bodies in their natural states. Guidelines and policies are still in their infancy, with international bodies like the United Nations Office for Outer Space Affairs working to establish frameworks that balance exploration with conservation. In conclusion, autonomous construction robots for off-world habitats are not just tools for building structures on other planets. They are the embodiment of our dreams to become a multi-planetary species. They stand as proof of our technological prowess and as symbols of our commitment to expanding the human frontier. As we continue to refine these machines, they will become our partners in the cosmos, building the bedrock for a future where Earth is not the only world we call home. The habitats they construct will be testaments to our vision, our resilience, and our unending quest to reach for the stars and make them our home.